Okay, in this tutorial, we are going to talk about partial fraction. Okay, now, if you know how to resolve a partial fraction, it's going to be very much easy for you to solve a question involving what? Integration by what? Partial fraction. Okay, so let's start. Let's say we have a function which is the integral over, let's have this, and then here let's put x minus 2, and then let's have x minus 1. Okay, then we have dx. So how can we resolve this one into partial fraction? Well, we know to say if you are trying to resolve a partial fraction, if you just have, for example, the way this function is, we are trying to come up with this. We are trying to come up with it. On top there, we are trying to resolve it in this way. So the way it is, we have 3x on top. Then here we have x minus 2. Then here we have x minus 1. So what we're trying to come up with here, we really don't know if maybe it was 3, maybe it was 3 over, maybe 3, maybe just like this, maybe it was this. We don't know. Okay? We don't know. So we are trying to come out from here, then we expand it in that form. Okay? So how can we do that? Now, to do that, what we're going to do is we're going to resolve it into what we call the partial fraction. So we're going to get this function. Let me write it from here. We're going to say 3x, then here I'm going to have x minus 2, then here I'm going to have x minus 1. So this one is going to be equal to, on top there I'm going to put a. We don't know a, but we're going to find the value of a, and then here then I'm going to pick that one, x minus 2. Then here I'm going to put plus. I'm going to put b, then here I'm going to put this. Now my goal is to find the value of a and b. So now what we are trying to do there is this is what we are going to have initially, meaning that that is the part which I'm going to plug in immediately when I do what? I resolve it into partial fraction. So now what I'm going to have is I want us to have this. It's going to be the integral of a over x minus 2 plus b over x minus 1. So this is what we are going to have. Okay, but now we are trying first to find the value of a and b. That is our goal. So let's go ahead and find the value of a and b using partial fraction. Okay, now what we're going to do there is I'm going just to put the brackets. Okay, I put the brackets everywhere. Then I'm going to do times. I'm going to do times the denominator. I'm going to do times both this guy and this part here. So I'm going to say here I'm going to have x minus 2, then also there I'm going to have x minus 1. Then now what I'm going to do from there is I'm going to distribute. I'm going to multiply everything here with what is inside. So as you can see, if I multiply this everything what is outside here with what I have inside there, then they are going to be cancelled with that one. So there I'm going to have 3x on is going to be equal to, if I do this part here times what is there, we are going to discover to say this part and this one, they are going to be cancelled. So I'm going to have a, then I'm going to have only this. Same applies to here. This part here is going to be cancelled with that part, so I'm going to remain with this part and b. So it's going to be b open brackets x minus 2. So initially that is what we have. Let me get rid of this. Okay, now we have an equation now which is 3x has to be equal to a, then we have x minus 1, then we have plus b x minus 2. Now our goal is to find the value of a and b. What do we do? Now what we're going to do is you are going to set these two things equal to 0, then find the value of x. So we're going to be plugging in one by one. So we have the first one which is x minus 2. Okay, so I'm going to set this one equal to 0. Let's solve for x. So x is going to be equal to 2, meaning that in that equation where there is x, I'm going to plug in what? 2. So let's start. First we are going to plug in 2. So we are going to say x 3, then here I put 2 where there is x. Here I'm going to put 2 minus 1, then plus, then here I've got b, then here I'm going to put 2 minus 2. So as you can see, this part here is going to give us 0. So we no longer need this part. it's going to give us 0, because 2 minus 2 is going to be 0. 0 times b is going to be 0. So we are remaining with only so 2 times 3 is going to give us 6. It's going to be equal to, this one is going to a, then inside there we're going to have 2 minus 1 is going to be 1. So meaning that a is going to be equal to 6. Okay, so now if a is equal to 6, what do we do now next? Now if this is the case, now we can see that now this is our value for a. We are done with a. Let's find the value of b. Okay, so we can just get rid of this and say, let's put a here. A is equal to 6. Okay, just get rid of this. Then now what we have remained with is x minus 1. So that x minus 1, we have x minus 1, we set equal to 0. So it's going to be x is equal to, if 1 goes there, we're going to have 1. So I'm going to replace now where there's x with 1 for me to find the value of b. So I'm going to have 3, 1. It's going to be equal to, what is my value of a? So my a is my x is 1 minus 1 plus b, then I have got 1 minus 2. So as you can see, this part we are going to be cancelled. It's going to be 0. So we're going to have 3 is going to be equal to b, which is going to be negative b. So therefore b is going to be equal to negative 3. So those are the values of, so the a is 6, b is negative 3. Then I'll go there now and plug in the values. Okay, so remember, let me just put it here. Remember, we have a is equal to 6, b is equal to negative 3. Then now what we are going to do now is this. Those are the values of a and b. What we're going to do now is this. We know that we said this is supposed to be the integral of a over x minus 2. Then you can say again plus the integral, or we do this. We put dx here, then plus the integral of b over x minus 1. So we have found the values of b. Now let's go ahead and find it. Let's go ahead and integrate this one. So here, let's not forget to say we have dx. So we're going to have the integral, the value of a is 6. I'm going to put 6 there over x minus 2 dx plus the integral of b is negative 3. So it's going to be negative 3 over x minus 1 dx. Okay, cool. Let's go ahead and integrate now. So this one is the same as, if I can shift the 1, I can shift the 6 here, then I put it outside, meaning that I'm going to continue from here, meaning that what I'm going to have is 6, the integral of 1 over x minus 2 dx plus, I can also put negative, it's going to be negative now, because this negative 3 I'm going to put it outside, so it's going to be negative 3, the integral of 1 over x minus 1 dx. Okay, now what else are we going to have? We know that, how do I integrate? If I'm trying to integrate, if you want to integrate, maybe we have 1 over x minus 2 dx. Integration of this one, how is it going to be? This is the same as if you do it the way we are doing it, it's going to give you 0 on top. So it's going to be like this, x minus 2 then to the power negative 1. Okay, now dx. Now we know that the rule of integration, we are supposed to add 1. So here, if I add 1, you're going to discover, say, it's going to be x minus 2, then it's going to be negative 1 plus 1, which is going to give us 0. So it doesn't work like that. So if you find that this is the situation which we have, meaning that that one is going to give us ln, because we know that if we are trying to integrate, maybe we have got ln x. Okay, it's going to be 1 over x. You see, so now if this is the case, meaning that we can say that this one is going to give us 6, then it's going to give ln, now it's going to be x minus 2. Now why am I putting the the modulus there? I'm putting the modulus there just because I know to say, if I remove the modulus, what if the x value was negative? Meaning that ln negative is going to be undefined. So now, to make this equation satisfied, we are going to put the modulus to symbolize, to say the only values which we need there inside is positive. So here we are going to say it's going to be also we are going to have minus 3, then it's going to be ln this one now plus c. But we should not forget to say, according to the rules of lin, we can just shift these two guys. If you want, you can put these two guys to be on top, then it's going to be ln x minus 2, then this to the power 6 minus here I'm going to have minus c ln, then I have x minus 1, I have this, then to the power 3. Okay, then plus c. So we can say that this is our answer. Okay, so now let's work out this example. Let's say we have 1 over, then we have 2, let's say we have 2x plus 1, and then also let's say we have x minus 1. How can we integrate it? The x. Okay, so this is going to be equal to the integral of a over 2x plus 1 dx plus the integral of b over x minus 1 dx. So our goal is to find the value of a and b. In short, if you are dealing with integration by partial fraction, just know to say the final answer is going to carry ln. Okay, so now what are we going to do? This one we are going to have 1 is going to be over, we have 2x plus 1, and then we also have, I can just put them in brackets, then x minus 1. Okay, so this is going to be equal to a over 2x plus 1, then plus b over x minus 1. Okay, so now what we're going to do, we are going to do times this guy everywhere. So here we're going to have 1 is going to be equal to, if I do this, the whole of this 1 times what I have there, this is going to be cancelled. We're going to remain with a open brackets x minus 1, then where there's b we're going to remain with 2x plus 1. Okay, now for us to find the value of a and b, our goal is to do this. We're going to set those guys inside equal to 0. So we're going to say that x minus 1 is going to be equal to 0. So we're going to get x is equal to 1. So I'm going to plug in where there's x with 1. So I'm going to have this a, then here 1 minus 1 plus b, I'm going to have 2 times 1 plus 1. Okay, so this one is going to give us 0. So what are we going to have? We're going to have 1 is going to be equal to 2 times 1 is going to be 1, then times 3 is going, plus the 1 is going to be 3. So we're going to have 3b. So to divide everywhere by this, by 3, then we're going to get that b is going to be equal to 1 over 3. We are done with b. Let's plug in the value of, so b is equal to 1 over 3. Let's plug in the value of what? We plug in the value of the equation which we had, this equation. Now we find that other one. So if we set this one equal to 0, what we're going to have? We're going to have 2x plus 1 is equal to 0. So we're going to have x x is going to be equal to what? Okay, so we're going to have x. We're going to have x is going to be equal to negative 1 over 2. So where there is x, let's put this negative 1 over 2. So what are we going to have? So as you can see here, if I plug in the values there, I'm going to have 1 this side. Okay, I'm going to have 1, it's going to be equal to, then I have a open brackets, here I put negative half minus 1, then I put plus, here I put 2 times negative 1 over 2 plus 1. So this, everything here is going to give me negative 1. So negative 1 plus 1 is going to give me 0, meaning that one has gone. So I'm going to have a 1 is going to be equal to, so we have now inside there we have the fraction which is negative half minus 1. So negative half minus 1 is the same as we have negative 1 over 2 minus 2 over 2, which is going to give us negative 3 over 2. Okay, so we're going to have negative 3 over 2 there. Okay, so we're going to have this. We're going to have 1 is going to be equal to negative 3 over 2a. So to find the value of a, what do? We can just do times the reciprocal of what we have there. So it's going to be negative 2 over 3. Even here is going to be the same, negative 2 over 3. So meaning that these two guys, they will cancel there, so we're going to have a is going to be equal to negative 2 over 3. Okay, so our value of a is negative 2 over 3. So you can get rid of this now. Now after resolving it into partial fraction, we now plug in the value of a and b, then we continue. Okay, so now what we're going to have there is this. We're going to have the integral of, where there is a is 1 over 3. So 1 is on top over, this 3 is going to be here. Sorry, a is negative 2 over 3. Okay, so negative 2 is going to be on top there, then over, this 3 is going to be down there, then we're going to open the brackets and say this. Okay, this, then dx plus the integral of b is 1 over the 3 we are going to put, because it's down there, so it's going to be like this, dx. Now from there we can now resolve this one into, so what are we going to have now? So the thing which we're going to have there is going to be what? It's going to be, we can shift these two guys outside, so we're going to have this. I'm going to have this outside, the integral of 1, I'm going to mean with 1 there, 2x plus 1 dx. Then here I'm going to have plus the integral. I can shift 1 over 3 so that this should be outside, 1 over 3. Then I'm going to have 1 over x minus 1 dx. Okay, cool. Now from there, what do we do? From there now, we know that this part is going to give us ln what is down there. This part is going to give us ln what is down. It same applies to that one. So we're going to have negative 3 over negative 2, sorry, negative 2 over 3. Then I'm going to have ln, then it's supposed to be in modulus, plus 1 over 3 ln x minus 1. If you want, you can end here. This is the answer. If you want, you can shift these guys to be on top, then you say that ln, then you have this. You know that the property of log allows us to shift this part to be the power there, so it's going to be negative 2 over 3 plus ln x minus 1, then this one is going to be 1 over 3. So this is the final answer. Okay, so the only trick part is you need first to resolve it into partial fraction, then now get the values of a and b, then plug in there and start working on it. Okay, so now let's say we have another one which is 4x plus 5, and then over, let's say we have x plus 2, and then we have also x minus 2. How can we do it? This is supposed to be equal to, we have dx, so it's going to be equal to, we are supposed to get the same issue, so it's going to be a over x plus 2 dx plus the integral of b over x minus 2. So our goal is to find a and b. So we're going to get that one for x plus 5, then we put x minus plus 2, then here we have x minus 2. So this has to be equal to a over x plus 2 plus b over x minus 2. So we are going to do times the whole of this equation times what? Times this, times x plus 2 times x minus 2. So if I do this part, everything here times what I have here is going, those two guys are going to be cancelled, and I'm going to remain with 4x plus 5 is going to be equal to, if I do this part times everything here, then the x plus 2 is going to be cancelled, and I'm going to remain with a x minus 2. Same applies to b. That one is going to be cancelled, and I'm going to remain with him x plus 2. So our goal is just to solve for x. So we're going to say that these two guys, x, another one is going to be x is equal to negative 2, another one is going to be x is equal to 2. If you set these two guys equal to 0, then you solve for x. So let's plug in 2 first. Okay, so if you get, it's going to be 2, then you have plus 5, it's going to be equal to a, I put 2 minus 2 plus b is going to be 2 plus 2. So what I'm going to have here, 2 times 4 is going to give me what? It's going to give me 8. 8 plus 5 is going to give me what? It's going to give me 13. So I have 13 is going to be equal to, this part is going to give me 0. So I have 4b. So divide both sides by 4, even here by 4. We can see that our b is equal to 13 over 4. Okay, now that one we can put it separate. Let's now get rid of this. Okay, we get rid of this. Now we're going to plug in negative now. So we have found that our b is equal to 13 over 4. Okay, so now let's find the value of a by plugging negative. So we're going to say that 4 negative 2 plus 5 is going to be equal to a, open brackets, I put negative 2 minus 2 plus b negative 2 plus 2. So as you can see, again, this part is going to be 0. Okay, so we're going to have negative 8 plus 5 is going to be equal to negative 4 a. So as you can see, this part is going to give us what? Negative 8 negative 8 plus 4 is going to give me negative 3. So I've got negative 3. Okay, I've got negative 3 is going to be equal to negative 4 a. Let's divide both sides by, I can get rid of this. Okay, let's divide both sides by what? We divide both sides by 4. So we're going to get our a is going to be equal to negative 3 over 4. Okay, so we plug in now there. So we have our a and b. So let me just put our a here to say it is negative 3 over 4. Okay, cool. So let's get rid of this now. So we know what to do now. We know that what we're supposed to have here is going to be the integral of a. The value of a is what? Is 13. Or the value of a is negative 3 over. Now this 4, you have to put these brackets here, dx. Then you have plus the integral of what is b. So you have our b as 13 over, then you have 4, open bracket, x minus 2. Okay, we also have the x. We can just shift these guys, the coefficient outside. So we're going to have negative 3 over 4. Then here I will remain with 1. Then here I will remain with this. Okay, the x. Here same applies to this part. It's going to be 13 over 4. The integral of, I have 1 over x minus 2 dx. Okay, so now from there we can now integrate now. So what's going to be? It's going to be negative 3 over 4. This one is going to be always lean, so it's going to be lean modulus. Don't forget to put modulus. Plus this one is also going to be 13 over 4 lean x minus 2, then plus c. Don't forget to put plus c because c is constant. Yeah, the last example which I gave you, I forgot to put c, but you are supposed to put c. Don't forget to put c. Once you forget to put c, you are going to get a 0. Okay, you can end there to say this is the answer, or you can say that if you want, you can shift those other guys to the top side. You can say that it's going to be lean modulus, you have x plus 2, then those guys is negative 3 over 4 plus, you can say also lean x minus 2, then that one is negative to a power negative 13 over 4. You can also say this is the answer. Okay.